Hello and good afternoon everyone, and thank you for joining our hybrid storage webinar today. So we are joined here by Max Brown from Pure Storage and then also Andy Hardy from Nasuni.
Thank you, Amy. So just to set the scene a bit, we'll just give you a kind of brief overview of what Pure Storage do and kind of what they offer. So, the title of this, these two presentations is hybrid storage. What we're actually kind of talking about is the type of storage that you could use for on-premise, which is what I'm going to talk about, and then the other side of storage is for things that may not have the need to actually live on-premise. So if we just have a quick look at what Pure do, essentially we have one product today, the FlashArray, which is designed for your block-based environments, for things such as virtual machines, for things like databases, for things like virtual desktop. Coming out towards the end of the year, we have a product called FlashBlade, which is targeting HPC environments. I'll also touch on the things which aren't exactly product related, but in terms of the cost of ownership and how we do things very differently from a whole array lifecycle perspective. So very quick potted history of Pure Storage. We were founded in 2009. We've been shipping product for just over 4 years. We have about 2,500 customers, about 5,000 to 6,000 arrays deployed worldwide. We are a global organization with over 1,500 employees. We only deal through partners, so we never sell direct, hence why we're doing this webinar with Bytes. From a support perspective, it's truly 24/7 follow the sun support. But the key thing about our support, it isn't just there for you to call up when things go wrong. It's about being proactive and predictive. So if we can identify issues before they become issues and fix them, we kind of nip these problems in the bud. So we don't want you calling our support. We'd rather we call you in advance and stop things before they become issues. And then lastly, we had to look at doing things differently from a business perspective in terms of how does support contracts work. How do you charge for the software, and what guarantees can we put behind that? I think one of the main validation points as well of the big list of customers, we've got customers ranging from everything like Domino's Pizza, doing all of their transactional website ordering storage, through to Betfair, through to Waitrose, to LinkedIn, to Barclays, to British Airways, and a whole host of people running their key critical mission-critical enterprise businesses on Pure. If you look at the Gartner Magic Quadrant that came out literally last month, so for 3 years in a row we are in the leaders quadrant. We've pretty much stayed in the same position. Some of our competition has kind of moved slightly to the left and slightly down a bit, but 3 years in a row Gartner have seen us as one of the leaders in the all-flash array field. So one thing to look at before I talk about the technology is, how do you procure and own storage? And generally there's a kind of couple of methods that have been used by all of the big vendors traditionally. And that's based on the fact that when you buy an array, you generally buy it with a 3 or 5 year support contract. At the end of that support contract, if you want to renew the maintenance, you get stung with a really, really large bill, hence we call it maintenance extortion. And there's no real reason that the price goes up after 5 years. It just does, because pretty much, to be honest, every vendor did the same thing. The alternative is to actually buy a new array. So, very often I speak to customers and they generally have a 3 or 5 year tech refresh cycle. In other words, they're just going to start all over again. They're going to do data migrations. That in itself is painful, because you are eventually going to throw away or do something else with your old array, which means you're pretty much getting rid of the storage you had and you're rebuying storage for the future. The risk associated and the downtime potentially with doing this is huge. This is why customers don't like having to do a tech refresh. Or you have a kind of scale out environment, which some of it might be software defined storage, could be hardware, but again you're taking out old nodes and putting in new ones, so you are in essence rebuying storage that you already have. So we have a completely different approach to the way you own your Pure Storage array. So we charge support like everybody else, but the big difference is, firstly, our support cost does not go up when you go outside of your maintenance contract. So if you buy it with 3 years or 6, 5, 4, whatever you choose, the support cost stays flat, and it stays flat forever. At no point do we put the support cost up. The only time you would pay more for support is if you actually bought more physical hardware. In other words, you bought another pack of drives. But if you didn't buy any more hardware, your support cost would stay flat. And in fact, in some instances, you may actually see the cost come down due to currency fluctuations, but we guarantee that even if the fluctuations went the wrong way, your support costs would never go up. So that's number one. You never get in a situation where you're going to get stung with a huge maintenance bill. The next thing we do is that every 3 years, as long as you're under a valid support contract, we will refresh the controllers in your Pure Storage array at no cost. So in other words, every 3 years you're going to get a nice upgrade to the biggest, fastest, to the bigger, faster model of what you've got. We design all of our architecture around Intel chips, so pretty much every single year with Intel release a new chipset, we release a new version of storage controller, and we've been doing this every single year. So this means that you never get left behind on technology. So when you look at it, this means that you never have to do a tech refresh. Literally, the array almost lives forever. So at the end of year 3, you commit support, you buy another 3 years, so 4, 5, 6. Again, as I've said, the cost stays flat, but you get these free controller upgrades, so you be going bigger and faster. But one of the other key things is these controller upgrades are done with zero downtime and no impact on performance whatsoever. And then lastly, we support everything forever. Now this might kind of sound a strange thing, but most storage vendors, if not all of them, have a finite point at which they will not support drives. So most vendors, when you get to year 6 or 7, if you have drives that are that old, if one of them should fail, it's down to the customer to actually purchase a new drive. We just saw that as a very bad business practice. So if you do have a drive fail that's in 7, 8, 9, 10, whatever year it is, you get the drive swapped out as you would ordinarily. Now if this means that Pure actually have to buy a drive, we don't pass that cost on to you. So in other words, you don't need to worry about things wearing out or am I going to have to pay more money, because your support cost stays flat. We support everything forever, and you're going to be getting free upgrades every 3 years. So if I just boil Pure Storage down into, kind of these 4 key pillars, and these would be the 4 pillars that I would want to see from anything in technology, whether it's storage array, whether it's a server, whether it's a network switch, whether it's even a piece of software. Now, although we are an all-flash array, we don't spend a lot of time talking about performance, because to be honest, most vendors have a flash offering, and it's going to be an order of magnitude faster than what most people are running. For us, the key aim of Pure was not to design the best flash array, it was to design the best storage array, but we saw that disk is going to die out, let's build it on flash because that is the future, and that's kind of been proven now. For us, the most important thing with storage technology is availability. Because if you don't have availability, it doesn't matter how simple, how cheap, or how fast it goes. If the availability is not there, then what's the point? And availability for us isn't just a binary, is it up or is it down? It's availability as in things like, I can't run my SQL batch job on Friday evening because it conflicts with another process that's running. In other words, I haven't got that availability to do what I want when I want. For us, availability is about having an array that's going to be trending towards 6 nines uptime. It's about not just having no downtime, but having truly non-disruptive operations. In other words, if I need to do a firmware upgrade on the array, if components are failing, if I need to run multiple jobs, my performance levels stay the same. So in other words, your workloads get a very predictable and consistent performance level. And we're talking kind of hundreds of thousands of IOPS at sub-millisecond latency. The array also needs to be simple. I guess the easiest way to explain how simple Pure is that we don't have an end-user training course, because there is no complexity behind this. There is no tuning, there isn't anything you need to design, there's no lengthy professional services engagement to get it up and running. I mean, it's literally half a day's job, and that would include training the end user on how to use it, which is about 10-20 minutes to show how to use it. The other side of simplicity is having the array kind of talk to support automatically. So every Pure array that's been deployed phones home every 30 seconds with detailed logs. So if our support guys, it's not just about having, a red flag item come up and something's gone wrong. This is about actually being predictive. So we may see something on your array that gives us cause for concern. We might start to see a pattern emerging. So you're more likely to get a call from our support guys saying they'd like to access your array to actually investigate something and potentially, put a patch on before anything does kind of go bad. So in other words, you really don't call us, we call you. We're watching the array, so you literally don't have to. It also needs to be simple to expand, which literally is you either put some drives in it or you attach an external shelf, plug it in, turn it on, and that's it. No professional service involved, no administrative work. You literally plug in a shelf, turn it on, and the capacity just appears in the GUI. So from a cost perspective, there's a few things we do. So number one really is we are a data reducing array. In other words, as data flows into the array, we deduplicate it and we compress it. So because of the algorithms we do it not only inline, we do some post-process as well, but we get the best data reduction out of any of the data reducing arrays in the market. And we've kind of proved this time and time again when we're doing head-to-head proof of concepts against some of the other major vendors out there. So that in itself means that you don't actually need to purchase as much storage as maybe you think you do. So for example, if you wanted roughly, let's say, 120 terabytes of usable capacity, we'd probably need to sell you somewhere around 40 of raw capacity. We don't have any software licensing, so all of the features are included, and any new ones, you would just get them free of charge. So whether it's things like replication or snapshots or plugins for OpenStack and VMware or encryption, they're all included at no cost. And then of course we've got the flat support cost, which means you're not going to be paying through the nose once you get into kind of year 4, 5, 6, 7, etc. And then lastly, don't forget you get free hardware refreshes. So literally the array lives forever. You will never get to a point with Pure where you think I need to buy a new Pure array to replace the one that I've already got. So in other words, it literally lives forever. We'd sell you a Pure array, we would never sell you another one to replace that one that you've actually got. And yes, it is fast, it's all flash, it's all sub-millisecond latency, but the way we've designed the array is it can handle any type of workload. So whether you're running let's say a 64K block size Oracle database, you could be running it on exactly the same array that's also running your 1000 VDI desktop deployment that generally has like a 4K block size. So regardless of the type of workloads, kind of OLTP type workloads, you can run them all together without having to worry. So it's the whole point that you just keep throwing your workloads at the array. So from a technology perspective, I kind of like to kick this off by explaining what you don't have to do. So if you ever have managed storage before, you will be familiar with things like RAID, with things like block alignment, trying to work out performance bottlenecks, trying to sometimes, some arrays you have to manually work out which controller is going to do which workload or has which LUNs, or which one's going to kind of do the lion's share of the work. There's no tuning, there's no tweaking. I mean, the simplest way to explain how Pure works is if you know what a server and a host name is, and if you know the difference between a gigabyte and a terabyte, that's it. That is all the knowledge you require to manage Pure. So we often sell Pure into environments where there is either no storage admin, or the storage admin doesn't want to get involved, or it's been sold to, like, let's say, a DBA team or a DevOps team, because it is that simple to use. So the actual array itself, I'll just skip to the next slide. It kind of looks like this. So this is a front and back view of the array. So it's a 3U array. Around the front it has 20 flash modules, which are basically the drives, and they are sold in packs of 10, and as you can see they vary in size from half a terabyte up to nearly 4 terabytes. We have these NVRAM modules, which is basically our write cache or write buffer, but this is kind of, they are all hot swap. They are external to the controllers. So on the right of the screen you can see we have 2 individual controller modules, and these are basically giant I/O processing engines. So as we said there, it's a stateless design. In other words, all of the important stuff, things like your metadata and your configuration data, is actually held on the drives and not in the controllers. And the way we kind of do the I/O balancing between the controllers means that when you pull a controller out, it might fail, or maybe you've got your 3-year replacement, or actually it could be that you're doing a firmware upgrade, in which case each controller will reboot one at a time. When a controller disappears, there is no impact on performance. It stays exactly the same. So most of my customers actually elect to do their firmware upgrades in the daytime because they know there will not be impact on their production environment. You compare this and contrast it to traditional giant monolithic storage arrays where this would definitely be a Sunday 3 a.m. job when the system's quiet, and there could be a huge amount of risk, and there's a lot of planning. So we've just taken all of that away. So in some ways it's kind of giving you like a cloud-like functionality with your own storage array. From an expansion perspective, as you can see, we have expansion shelves. So our largest shelf goes up to 90 terabytes raw. Literally just plug it in, turn it on, and you have more capacity. And from an I/O perspective, we run 8 or 16 gig fiber channel, we run 10 gig iSCSI, and you can run a mixture of both on the controllers themselves. You don't have to choose fiber or iSCSI, you could run both. So as I kind of mentioned earlier, the array does live forever. So on the far left-hand side of this slide, this is the original array that we designed, which was actually based around 2 Dell servers that we kind of built as storage controllers. Then once we got to about 1,000 customers, about 18 months ago, we decided that enough's enough. Let's design our own hardware, because if you've got this situation, if I look at a lot of storage arrays, they tend to be software that's running on somebody else's hardware, whether they're using super micro servers or somebody else. But we said that the whole point of a storage array is the hardware should be tuned to work with the software. So we came up with our own hardware design, so every single component inside the FlashArray M is designed to work as an all-flash array running the Pure Storage code. In terms of migrating, well, actually that's the wrong phrase. There is no migration between any of these models. It is just an upgrade. So even if you started on the left with the old version and then you moved to the new type of array, these upgrades are done non-disruptively, no downtime, and more importantly, no performance loss. So whether you're starting with the small M10 and you're going all the way through to the M70, there will never be any downtime, there will never be any interruption to your data, there will never be any performance hit. And whatever we design in the future, and we reckon this chassis is going to be good for about 7 to 8 years, whatever we design in the future will be backwardly compatible. So you will never get stuck on a piece of Pure Storage hardware and then have to buy something new to replace it. You will always be upgraded. So you will just be adding capacity, and that's literally the only thing you would ever have to do, because we would replace the controllers every 3 years. So it is all powered by the clever software that we've got, everything from the data reduction technologies such as deduplication and compression, as well as protecting you against any kind of failure. So although you don't set RAID or think about it, there is some RAID algorithms running in the background so that you could have a simultaneous dual drive failure in every shelf and the array would still continue to run. We've got end-to-end encryption, again that's all built in, and to make things simple, we do not allow end users to actually turn off deduplication or compression or encryption. Again, this comes down to the simplicity. If you start giving users options to turn things off and turn things on, it creates a lot of if-then statements, which we're just going to take that completely off the table. We've also got snapshots built in, so we can take tens of thousands of snapshots. You can replicate from one Pure Storage array to another one. And again, all that software is completely included. There is no cost whatsoever. And then under the covers, there's some very clever technologies, which I won't go into now, but in terms of how we manage the flash, how we do the I/O scheduling, this array has been designed from the ground up to work with flash. It's never been designed to work with spinning disk, because the way spinning disk and the way flash works is fundamentally different. Although there are a lot of vendors who now have an all-flash array, which is basically a retrofit. So it would be their traditional storage array, and now they fill a load of SSDs in there and tweak it slightly. That's not really a scalable model. What you need is something that's been designed to work with flash and with flash only, because it is a very different technology. So it is a very simple deployment. As you can see, it's a 3U chassis. You've got a couple of power cables, a couple of management cables, and then however many SAN cables you want to put in. There's no data migration, everything is done online. You don't need any separate appliances to manage it, you don't need any VMs. I mean, there literally is nothing extra that you need for this. And then lastly, it is an array that you don't have to worry about, because everything can be upgraded online. There's no performance issues, whether things are failing, whether they're being upgraded or whether they're being replaced. So I'll just touch on our support model very briefly. So as I mentioned, the arrays phone home every 30 seconds, so this means we get massive visibility into what every single array is doing, and that helps us prevent issues from happening. So if we do get a new bug occur, it really means that one customer experiences that bug once, because we can then triage it, we can then scan all of the logs from all of the other 5,000 or 6,000 arrays that are dialing home, and we can identify any other customers that may be at the same risk, and then we can patch those systems before it even becomes a risk. So it's very predictive support rather than reactive. So that's it from me. If you have any questions, feel free to put them in the box. And now I'll get Amy to hand over to Andy.
Okay, thank you, Max. Right, I'll just pass over to Andy now.
Okay, g'day everyone. I hope you can all hear me. Thanks, Max. Good afternoon, everyone back in London. My name's Andy Hardy. I'm responsible for Nasuni's business in Europe. Nasuni essentially complements Pure's on-premise block storage all-flash arrays by focusing on your unstructured file data and moving that to the cloud. We thus transform file storage and the backup of files and the DR of files from CAPEX, capital expense, to a variable operating expense model. So as I mentioned just there, Nasuni essentially replaces on-premise file storage arrays, NetApp, etc., and frees up the block storage capacity so that Pure can focus their performance around the databases, etc. So what we want to do is move the unstructured file data, which is clogging up lots and lots of terabyte capacity in people's data centers in their remote offices and branch offices today. We're going to move all of that into the cloud. Typically we work with Microsoft Azure. We do also work with some other private cloud storage platforms as well. And this gives us a way to significantly impact the cost of file storage, backup and DR. And we've done this for hundreds of customers globally, well over 300. We've got more than 20 billion files stored this way, dozens of petabytes in total today. So as I mentioned a moment ago, if you look at the chart on the screen here, the green part of this represents the unstructured file data, which for lots of people represents a bit of a challenge in terms of not so much performance, but also in terms of the scalability of that capacity, people having to focus on how to deal with the growth of that capacity and having to migrate through storage refresh after storage refresh, as you've heard from Max a moment ago. They've also got to figure out how to back up and DR, replicate that data as well, which can be an expensive hobby. And increasingly, our staff expect to have global access to that file data, whether that's in your branch offices around the world, whether that's from their mobile devices as they travel, and getting the same performance when your applications access those files, no matter where you are in the world, can be a challenge as well. So if you're like most people, your traditional file storage infrastructure is something which drives a lot of cost and complexity. You typically see several copies of the data for backup and disk to tape to off-site and replication copies, and then there's your branch offices and remote locations which are using various technologies to somehow gain access to that same data. There can be performance challenges around some of those technologies for offices which are distributed around the world. And as I mentioned a moment ago, increasingly people want to get mobile access to that same data. So we start layering on other technologies, making this even more expensive, even more complex, and the larger and more global your business is, the more this becomes like knitting with spaghetti, and everything just becomes rather challenging to manage in that regard. So this is the set of problems that Nasuni Enterprise File Services, Nasuni Cloud NAS, seeks to address. By working with public cloud storage platforms like Microsoft Azure, as well as private cloud object storage platforms, we are able to produce a single global file system. We call it a unified file system. That's what we've created. Is called UniFS, hence the name of the company, NAS, Uni, Nasuni. We give you a single pane of glass, the Nasuni Management Console, which lets me manage all of the file storage for all of my offices as if it was one big filer. That could be stuff that's in New York, London, Paris, Munich, Uzbekistan, or Peru. But of course the difference is that rather than just putting it in the cloud and having people remotely access it somehow, we're able to make this perform as if it was local. And the way that we do that is we put some low-cost technology on your premise. That might be low-cost appliances, or very frequently it's just a virtual machine that we give you for free, which you can run in Hyper-V or VMware. And what this appliance or filer does on your premises, we might be replacing hundreds of terabytes of file data. We'll only need a couple of terabytes, a few terabytes of disk in the appliances that we use to replace that, because what we actually do is we have that appliance behave as if it was kind of a Windows file server. It serves up CIFS and CIFS and SMB and NFS, for example, integrates with your Active Directory, etc., etc. And then instead of just storing it locally, We then go further. We compress it, we deduplicate it. Very importantly, we encrypt it with encryption keys that remain with our customers so that no data leaves your premises until it has been encrypted with keys that you keep, which means that no third parties can access that data. We break it down into chunks, into objects, and we serve it out the back in parallel for some WAN acceleration and get that out into the cloud. Typically, for example, in Microsoft Azure, we would leverage their GRS, their geo-redundant storage, and each of those objects is then going to be stored within Azure up to 6 times in multiple racks, in multiple data centers, in multiple geographies, if that's what you would like. So you end up with an extremely robust and scalable file system. None of the filers on your individual sites will ever fill up because the primary copy of the data is always copied into the cloud. Your user's performance experience is that of a local NAS filer. And then we augment what these on-premise appliances do with some additional services that we deliver from the cloud. So I'll just explain a bit more about that. So first and foremost, this is about ensuring performance. So my offices in New York, London, Paris, Munich, Uzbekistan, and Peru that I mentioned before will all believe, and it will seem to them that they have a local file system. The big difference, of course, is that if we put something in the file system in London, the guys in Paris and Munich and Sydney and wherever else in the world will see the same content in the same paths. So that gives me a way to enable collaboration around the world, but most importantly, it still performs like it's local. When I write, when I read data, I'm reading from that local device. It does also, though, let us scale infinitely. Those appliances just keep growing infinitely. You don't have to ever take them out and add more capacity because we leverage the scale of the cloud services, the cloud object storage behind there, whether public or private. Now, we implement on top of that a global file system. That includes, for example, the ability to have the same metadata visible for the file system in all locations. That includes the ability to have things like global file locking, for example, and we have the most scalable technical design for global file locking in the market. We do this for customers with hundreds and hundreds of global offices and petabytes of storage, as well as for customers with tens and 20s of terabytes of storage and 3, 4, or 5 offices within the country or around the world. We also take care of protecting file data. Data protection is a very important aspect of what we do. We provide literally limitless file snapshots. So we enable our customers to snap the file data every minute, and you can keep those snapshots forever. You can set retention periods, of course. And that gives us an extremely robust form of file data protection with instant recoverability for files. And whether individual files or whether entire paths or volumes of file data. And that means that we not only replace the on-premise file storage capacity in our customers' premises, but we also replace the backup capacity that goes with it. Most of that backup capacity is licensed depending on how much you use of it, so that immediately reduces those costs as well. And as I touched on earlier, because we're leveraging the power of object storage in the cloud to have multiple copies of objects all around the place, it means that we don't need to have a separate replication of file data. We don't need to have a separate DR. The DR is already built in. So those items are addressed as well. I touched on the security. We believe in customer-controlled encryption. That's very important in this particular time frame because the European General Data Protection regulations are at odds with the regulations in the US, which since the demise of Safe Harbor basically mean that the US feds can ask for access to a lot of file data that's stored in the cloud. We overcome that by ensuring that before it leaves any of the files on any of your premises, that data has been encrypted with encryption keys that our customers control. So no third party can access that data. The data is effectively deregulated before it leaves your premises. And lastly, we also build in mobile data access to the filer data. We do that in a number of ways. We have sync clients that go on your Windows, Mac, and Linux machines so that when you get off the plane or get off the train, you can synchronize, and a certain set of paths in the filer, the big filer in the sky, if you like, can be mapped to individual folders on your laptop, and you can synchronize in that fashion. There's also a web portal which can be rebranded by our customers, which give you access to the file data for your staff as they travel, perhaps for DR purposes. And also you can set up a two-way file sharing there so that external third parties and consultants can access that data. And we also have apps for Android and iOS to access that same data as well. So let's just focus on the financial side of this. The reason that we're doing this, and I believe the strongest reason that people want to move their file data into the cloud, is to transform that capital expense where we historically invested in infrastructure. We had to guess how much file capacity we would need to store over the next 3, 4, or 5 years. We transform that into a variable operating cost. And that means that you pay per terabyte per year. You pay just for what you use. If you need more, you pay more. If you need less, you pay less. And if your strategy changes, I found in a past life when I was IT director of one of the global investment banks, it was very difficult to predict what the business would need from us in the following year. And if your strategy changes, you just don't pay it again. You do something different. So there's no lock-in with this strategy. It's a truly as-a-service type of solution. So Nasuni replaces that on-premise primary NAS storage. We free up capacity in your existing storage arrays to use for other purposes, such as block storage. That's one of the great reasons why we work together with Pure, and I'll give you a customer case study example of that in a minute. We obviate the need for a separate file backup and replication environment. And a lot of people are using things like WAN optimization and VDI just to gain access to files that are far away from branch offices. We take away that issue as well. All of your branch offices will perform like they have the files local. And that is replaced then by a per terabyte software as a service license model, per terabyte per year. And we sell this on a zero CAPEX model. That should say zero to low CAPEX, not OPEX there. I'll fix that later. And that's because the appliances that we put on premise are very low cost. That's not how we recover our software licensing. We do that through the per terabyte model, or it can be a zero CAPEX cost if you have if you choose to take use of our virtual filers. So just to wrap up, you know, everybody shows lots of logos and says they've got lots of customers all over the world and gives you all sorts of wonderful stats about how big we are and all the rest of it. Just to give you an idea, we are seeing adoption of this technology all around the world. That's for global corporations as well as local corporations that just need their people everywhere to have access to that data. For example, Perkins & Will. They're the 5th largest architecture firm in the world. They need their staff globally to be able to access their CAD models and their Revit models simultaneously from multiple offices so that they can have their customers acting locally but delivering globally for their customers, leveraging resource and human resource capacity, engineering and architects that are available wherever they may be in the world. In that case, we replaced NetApp storage with about 100 terabytes of Azure-based public cloud file service from Nasuni. And this enabled global file sharing, leveraging our global file locking, enabled much more robust data protection for their files than they had before, and of course they benefit from that unlimited scalability that I touched on earlier. Another example here in the UK is Condé Nast. Condé Nast UK are publishers of magazines like Wired UK and Vanity Fair and Vogue and all of those. This enabled them to shut down one of their data centers in order to reduce costs, because we took away the file storage problem. They still have block storage, which is used for their block storage needs, databases and so forth. We've actually freed up capacity in those systems so as they can focus more of those spindles on delivering performance for those applications. But the file storage, its backup and its DR is now all in the cloud. And another customer of ours is AvMed. They're a health insurance provider in Florida where they have 7 locations around the southern parts of the United States. When we work together with our friends at Pure in order to replace EMC VNX and NetApp storage in that particular case. So we've delivered, you know, tier 1 NAS file storage as an alternative to the way that they were doing that before. That's all delivered through the cloud. The file backup is taken care of, as is global file sharing and disaster recovery. This does save people quite a lot of money. on the file storage costs around file storage, backup and DR, we can typically reduce those costs between 40 and 60%, and we do have an online calculator that will help you estimate that and will generate a personalized report for you if you'd like to look at nasuni.com/TCO. And we have helped hundreds of customers to do this. So just before I hand back to you, Amy, I'll just point out that there is a link at the bottom there which customers can look at to get more information and to arrange for a free demo. So with that, thank you very much, and I hope that was helpful. We'll see if there's any questions. Back to you, Amy.
Brilliant. Thank you so much, Andy. Okay, so we are going to open up to any questions. So if you do have any questions at all, there is just a questions box which is just at the right hand side of your screen. If you pop them in there, I can read them out for Andy and Max shortly. Okay, Andy, I've got a question here for you. It says, given concerns about data privacy and the loss of safe harbour protection, how does Nasuni keep customers' data private when stored in the public cloud?
Oh, look, that's a great question, and I think it's a huge concern for people in Europe. Just to recap for those that aren't familiar, there's some legislation in the US called the USA Patriot Act, which means that cloud storage providers such as Microsoft, who are fighting this in the courts, and Amazon and Google and all the rest, are required under US law to hand over data stored in the public cloud to the US government agencies if they are requested to do so. And they must do that even if the data has been encrypted in the cloud. They must decrypt it if they have the keys. And this applies not only to data that is stored within the United States, this applies to data which is stored by those firms anywhere in the world. And of course, that's in direct contravention of European data protection regulations, which despite Brexit, the UK is still subject to for the foreseeable future. And so that means that a lot of customers do ask, well, how can we be sure that our file data, which will often include customer data and regulatory data and so forth, when stored in the cloud, how can we ensure its privacy? And that's why we think it's so important that that data should be encrypted before it leaves our customers' premises, before it leaves those appliances. And the real clever part of this, the hard part, if you like, is not the encryption. Encryption's at a high standard, is kind of a commodity these days. The important thing is where you do that, and the challenge of doing that before it leaves premises in a solution like ours, where everybody has to be able to access the files without having to bother about the mechanics of decrypting those files. That's a big part of what we need to do, and that's the key management, which happens transparently and automatically. That's actually because one of our founders was one of the authors of OpenPGP, and so we're able to securely move the keys to the right files completely automatically and transparently, so that even though all of the users of that system will just see plain ordinary file access as if it was local, in fact that's all stored in the cloud and it's all encrypted. But with encryption keys that don't allow any third party to access that data unless you choose to give them those keys. I hope that's helpful.
Thanks, Andy. I think that's all the questions we got today. So thank you everyone for joining, and thank you Max again and Andy for presenting on the webinar today. And as mentioned at the beginning of the webinar, if you would like any more information on Pure Storage and Nasuni, if you could just pop that in the critique form at the end, one of our specialist bites will be in touch. Okay, thank you, and enjoy the rest of your afternoon.
Thanks, Amy. Thanks, Max. See you later.
Thank you. Cheers. Bye.